Let's look at next past question in the study of hydraulics and hydrology. I have created a playlist. By playlist, I mean a set of arranged video. That's playlist. So I have created a playlist for the course called Hydraulics and Hydrology. If you're interested in learning the calculation aspect, I didn't do the theory. I didn't do the theory aspect. I focus on the calculation aspect, right? So if you're interested in learning the calculation aspect, go to my channel, go to playlist. Under the playlist there, you see a course called Hydraulics and Hydrology. Click on it. It gives you all the calculation I've done so far in the study of hydraulics and hydrology. Let's take this example and see how it works together. It says an open channel is V shaped, each side being inclined at 45 degrees to the vertical. If the rate of flow Q is 0.0425 meter cube per second, when the depth of water at the center is 2 to 5 millimeter, it says calculate the slope of the channel using the Chezy formula, assuming that C is 49 SI unit. Alright, first task in science is that after reading out question, your next priority is to set out to write what the givens. So in this case here, what are my given? So given, alright, what am I given in this case? Please, it says an open channel V. By the way, the diagram attached to this question is this. The diagram attached to this question is this, please. Is this. Alright. The diagram attached to this question is this, please. Alright. Alright. 2 to 5 millimeter. Alright, this is the V-shaped water V concept. It says an open channel V-shaped, as you can see here, each side being inclined at 45 degrees, 45 degrees there to the vertical. Alright, it says if the rate of flow Q, alright, I'm given Q. First, I'm given angle, right? If I want to, perhaps I'm given Q first. Q there is 0.0425, of course, meter cube per second. Meter cube per second. Next up, when the depth, that's D, of water at the center is 2 to 5 meter. So D, which is the depth, is 2 to 5 millimeter. Please convert 2 to 5 meter to meters. You have 0.225 meter. How do you do that? Divide the value by 1000. You have 0.225 meter. And next it says calculate the slope. By the way, in hydraulics analogy, there are two slopes there. We have the base slope and the side slope. But in this case here, we are asked to find slope of the channel. That's your base slope. So it's called S naught. This is S naught. It's called S naught. This is called base slope, please. Bed, like this is BED, bed slope. This is a symbol for base slope. We are asked to find base slope is unknown. In that sense of the channel using the Chezy formula, assuming that C, this C, which is Chezy formula, is given by 49 SI units. So C is a constant known as 49, right? C is 49 in SI units. All right, I just list out parameters. Let's solve this question. Now I'm seeing Q, I'm seeing S naught, I'm seeing C. I expect that this is not your first class you're watching under this concept. In our very first two calculations we have done, I've introduced some formulas. So by now you should know the formula I'm about to use here. I mean, you're familiar with the formula I'm about to use in this case. So in this case here, the formula to use in this case, it's simple as observe this thing, please. We know that I'm looking for S naught. S naught exists in one formula I know so far. S naught exists in mean velocity. So recall that from mean velocity, that's V, we said V is equal to what? C root R S naught. This man is called the mean velocity under hydraulics and hydrology. This is formula for mean velocity. You can see that in this mean velocity there, S naught is there. So yes, that is there. To get S naught, I need three things. What and what? I need V. Please, am I given V in this case? No V. Here's the tax now. I have to look for V. Case 2, am I given C? Yes, C is constant, 49. C is not called constant by the word C constant. This C is called the Chezy formula, right? Next tax there. C is, I know C. Please, I don't know R. R here in this case, R is called the hydraulic radius. And R is equal to area over perimeter. That's formula for R. So in this case here, I don't know R, right? So what do you do in this case? First, my tax is easy as I don't know R, I don't know V. What do? I know C. I'm asked to find S naught. Now here's the tax. Our first is first. Look for R first. Let's do for R first. Let's calculate for R. Let's do R calculation. Right. Calculating for hydraulic radius, that's in brackets R. All right, that's R. What do we know? Recall that in this case here, R is given as area of wetted perimeter all over the perimeter, area of wetted part of the shape all over the perimeter of wetted part. That's how you look for R, and R is hydraulic radius, right? So let's look for area and get the value. Let's look at perimeter and get a value. We'll put the two values here to get hydraulic radius. Now for the area, the area of course in this shape is that observe this shape here. I have this shape triangular in nature. So yes, I have to apply the concept of area of a triangle, that's half base times height. Observe that this one here is one triangle, this one here is another triangle. That becomes a true triangle. So I should have 2 in brackets. What formula for area of a triangle? That's of course half times base times height. All right, I have this formula. This one here is formula for area, right? But this 2 means I have two shape, two area here, right? Two triangle, one triangle, two triangle. That gives you 2. Then into this shape is area in nature. The formula of area is half base times height. I use this concept so that you won't get confused and you won't take it. It won't take you too much stuff to put. I can still use sine rule to get this concept, but yet I just choose to use a simpler procedure this way so you can get it easier, right? All right. So from here, what do I do next? It's easy as the area in this case becomes 2 of the area of a rectangle, of a triangle per se. So here's that now. In this case here, in this diagram, I'm not given breadth or height, although I'm given just ordinary depth. So in this case here, both my depth and height represent depth. I mean this B and H. So I will let B and H be called D. Why? Because I'm only given depth here. So in this case, my B and H becomes depth. So I'll be having, in other words, I'll be having the area of this shape to be equal to 2 into half times what there times d squared, because if B is D, H is D times D gives you what there, a D squared. So I have D squared, then close the bracket this way. So yes, I there we said for this shape here in the question they gave us all these parameters in the question. How good? We are asked to find S naught, and S naught is called the best slope, right? So best slope is only found inside this formula. This formula is for mean velocity, and V is what? C root RS naught, Abi. So yes, I there now. I don't know. Now listen, I'm looking for S naught, Abi. I don't know R. I don't know C. I don't know V. Though C is given in question as 49. C is given. I don't know V. I don't know what. S. No, I don't know R. I'm asked to find S naught. I need three things. V, C, R. I know C. I don't know V and R. So task is to find what? V and R. How do we get R? R is called hydraulic radius. And the formula is given by R is what? Area over perimeter everywhere you go under this course. Are we good? Now, first task, look for area. In this case here, this shape look triangular in nature, and I have two sides of the shape, Abi. Triangle, triangle. How good? So I have two, that is triangle, into what's the area of a triangle normally? That's what the half times width times height. In this top here, there's no height, there's no base. I will have one thing, that's what? The depth. So change B and H to what? The depth. So it means I'll be having depth. Depth times depth gives what? The depth square. I have depth square here. Put in your value, what do you have here? The area A in this case will be equal to 2 into 1 over 2 times what's D? This value here, 0.225, or what there? All squared, of course, square brackets here. Of course, square brackets. Give value, please. Area in this case gives you 2 into half here gives you 0.5 times, please punch. What is 0.225 square? What do you have there? 0.225 square gives you what? All right, so let me try to punch that out. Let's see. 0.225 times 0.225. What do you have there? 0.050. Are you sure, please? Okay, 50. Let's say 6. Let's look at this 6. All right, I have this one here. Please help me multiply the inner one. 5 times this value. What do you have? I'll take this one. Okay. You can snap it, please, for reference sake, so I can, in case we're trying to recall a value. Should we proceed? All right, let's get area, please. In this case, we'll take this off. All right, the area in this case becomes A is equal to 2 is still left, Abi. Please multiply this one. What do you have there? The inner part and what do you have? Into 0.5. 0.5. Yes, 0.5 times 0.0506. This gives you about 0.0253. Multiply this value by 2. What do you have? The area of this figure times 2, 0.05. Perhaps I can stop here, or approximately 5, Abi. In what there? In meter square, because area is in meter square. So this is a value for the area of this figure. Are we good? My purpose is to find R, Abi, and in R I need two things: area and what? Perimeter. I've gotten area. What next now? The perimeter. All right. So let's do calculating for perimeter. Calculating for what there? For perimeter. What do I get? That's P. In this case, please, for this shape, please, for this shape V, yes, I did, please. In exam, the human will not change value. The home farm will only repeat what is in the question, like in the PDF for you. And I've done all the videos, so all the problems in the PDF, right? So just right there, just identify each shape and know the kind of formula we use for the area and what perimeter. For this one here, the perimeter here used here, the perimeter used is the two form. Either you go to first form or what second form. But here's like that to save time, perimeter in this case will be equal to 2, that same 2 idea. How good? The 2 idea we use 2 times d root 2. All right. So for perimeter of this shape, I have 2. That is 2 triangular in shape, nature. Then d is what the given depth. Then root 2. How good? Now put in value. What's b here? D gives you 2 times. What's d? D gives you 0 point something, 0.225. All right, 0.225, then times what? Times root 2. Please press all this on the calculator. What's p? Let's get p. Everything, Abby? Or are you press this one, root 2? Everything, Abby? So p gives you what? 0 point what? 0.636, Abby? Right? In meters, how good? So this is the value for perimeter, Abby? How good? Now I've gotten perimeter and what? Area, Abby? What am I looking for? Perimeter area. To get R. Abby? To get R. I've cleaned it. So we said, hence, R now is what? Area over what? Let's get R. What's area? Check this one. 0.00, sorry, 0.05 all over what's P? 0.636, Abby? Divide the two, what do they have? Divide the two, what do we get? The two, Abby? So your hydraulic radius R is what? 0. What? 0.7, approximately 9, Abby? All right, 0.9 what? Meters. That's your R. I've gotten R. Please, we said we want to get S naught. And we said the formula is V equal to what? C root R S naught. We said we need C is given, Abby. Yes. We have not known R, Abby. Yes. What's remaining? Remaining Q, V. Abby, remaining V. Yes. If I can get V now, I'll put a value I can get S naught. Now let's get V, please. The task is to get V now. Let's get V. Let's get V. All right. How can I get V? It's easy as from here, I want to get V. Perhaps, listen, perhaps I can do this way. What do we know? We know that Q is equal to what? AV, discharge. Abi, we know this. Now, I also know that, but we just said that V is equal to what there? C root R S naught. Now, I can say anywhere I see V, I can put what? C root R S naught. I can say that this charge Q can be expressed as A, how good? Then what's V? You said V is what? This one here, that's what? C root what? R S naught. So I can use this formula to get my S naught too. Yes, because Q is given in the question. A at Y already, this A. Sorry for the language. But I've gotten A already, this A, right? C is given 49. R is given already. We have no R. This is our R. Then we can get S naught. Instead of wasting my time to get velocity again, I can improvise to get what? To use this one here. So let's not use formula here. Let's see what we get, please. So from here, I'll take this off. Let's get S naught from here. Take this one off. Take this one off. Let's see what we get from here. Please, for this shape, your perimeter becomes 2 times d root 2. Your area becomes half 2 into half times d squared. for this V shape, please. All right, so that's basically that. Now, I want to get S naught. My task is to make S naught subject, Abby. So I'll have to take the square of both sides. How good? So take the square of both sides. Take the square of both sides. That is, I'll have what? Q square. Am I correct? Q all square is equal to what? AC square root of R S naught, or what there? All square. Apply indices concept. This gives you Q square, gives you Q square B equal to this square at come to A, gives you A square, C square, square and square to cancel out B, gives you what? Just ordinary R and what? S naught. How good? Now I'll make S naught subject here. How? I'll divide both by what? I want to make S naught stand alone. So it means this one must what? Must be erased, Abby. So that this one can stand alone, Abby. So it means I have to divide both sides by what? A square, C square, and R. Because I want to make S naught stand alone. So this one must be edited. So I'll divide both sides by what? By A square, C square, and R. So it means I'll have Q square over A square, C square, R equal to A square, C square, R S naught all over A square, C square, R. This man cancel this. So S naught is now equal to what? Q square all over A square, C square, R. Let's get the value of S naught. Please okay. From here, so S naught now, this S naught is equal to Q square. I have Q square all over A square, C square, R. Give me value, please. What's Q? Check what's Q. Q was equal to, Q is 0.0425. By the way, it's square. I have to square it all over A square. Check your area. What is your area? Meter cube per second. Yes, correct. We're not converting, right? So what's your A? Check the formula there. A gives you 0.0506 Abi. Or what there? All square. What's C? 49. All right, C is 49. I have 49 all square into what next there? What's R? We got R somewhere. 0. What? 0.079 Sabi. 9. We said okay. 9 Sabi. All right. Please multiply this. Let's get S naught. So in this case, S naught, which is best slope, will be equal to this one here gives you 0.00180625 all over. Multiply this together. What do you have there? So this one alone square gives you 0.00256. 6 what? 2560 exactly times 49 square gives you 2401. How good? Times, drop this one back, 0.0796. Now repeat down your numerator. S naught will be equal to 0.00180,625 all over. Multiply the numerator, everything. You will have about 0.4887. Please confirm this answer. Multiply everything here, you have this answer. So S naught in essence will be equal to, divide this by this, you have about 0.0036. Please, S naught has no unit. So this is my answer to S naught. So that I solve this particular question for a V shape of this nature. So any confirmation, please? Any confirmation? Is it correct? Like everything? 0.489. For AC, okay, approximately it's the same thing. So divide this by this, what you have there. You should have the value, please. So we'll look at the second past question under hydraulics and hydrology. All right. All right. How good? Confirm, please. Correct, Abby? So let's do this on that first question, please.
I just launched a book called The Shortcut to Academic Success. In this book, I share a lot of experience on how I evaluated during my time in school. This method really helped me a lot. If you're interested in getting this book, simply chat me up through my WhatsApp number that is shown in the screen,